Today, I'm going to show you how to calculate the tangent line to a point on a curve. How to calculate the tangent line to a point on a curve. If you have a straight line, here's an example of a straight line. Here's another example of another straight line. This is any f of x for this case, maybe g of x for this case. This is the x-axis. You can always find out the slope of the curve quite easily for any straight line. But if I were to draw a curve as an example here, well, the tangent to a point on a curve would depend on the point itself. For example, if the point was here, the tangent line would be here. If the curve was here, the tangent line would be here. So as you can see, these are different tangent line, two different points on the curve. This is one point, this is another point. So the tangent line to a curve depends on the position of the curve. I will now show you how to find out the tangent line to these points. Before we go on, I'd like to define what is a tangent line. Basically, a tangent line is just a line which just touches one point of a curve. So a tangent line is a line which just touches a single point on a curve. I need to define another type of line called a secant line, S-E-C-A-N-T, secant line. And that line, secant line, is defined as a line which intersects 2 points on a curve. So a tangent line is a line which just touches a point on the curve like this. A secant line, let me draw you an example here, would be a line which intersects 2 points on a curve. For example, let's pick the point here and let's pick another point here. So a secant line would be a line which would go through, let's say, this point and this point would be a secant. This would be defined as a secant line. There's an example of a secant line, and this is an example of a tangent line. This is an example of a secant line, a line which intersects 2 points of a curve. This is the first intersection, and this is the second intersection. Tangent line is a line which touches one point, one point on a curve, which is right here. Okay, given this definition, I will show you how to calculate the tangent line to a point on a curve. Basically, we are going to calculate the tangent line of this curve. This curve here at this point, we're going to calculate this tangent line. Okay, let me go on to the next page. I'm going to draw another line, another curve right here to show you. Okay, this would be a typical curve. I have a whole bunch of nice colors. I'm gonna pick another color to draw my curve. Let's say gray, and we would have 2 points. Let's pick 2 points to be our secant, which I've defined previously. A secant, a line is a line which cuts through 2 points of a curve. So these are the 2 points, and I'm going to draw my secant line here. Let me use a ruler, then it can be straighter, slightly straighter. Okay, this is my secant line right here. Okay, is that clear? All right, very good. Now what I want to do is I want to draw a tangent line. Now that I've got a secant line, which is a line intersecting 2 points of curve, I'm going to draw a tangent line. This line is basically tangent to my curve. Going to use brown. Oh no. Pink. Pink is nice. Gonna draw the tangent line which goes through like this. This is the tangent line which I've just drawn. So this is the secant, this is the tangent. Let me label them. Secant, S-E-C-A-N-T, and tangent, T-A-N-G-E-N-T. So now what's the relationship between a secant line and a tangent line? Well, let's find out. I'm gonna draw a few other points for you, and then from there I can show you the relationship between the tangent line and the secant line. They are actually very closely related. I'm gonna drop a point right down to the x-axis right here. I'm gonna drop another point. This is another point in the x-axis right here. Okay, very good. And then I'm going to draw a horizontal point right here. Okay, very good. Right now, I'm going to label this point x0, which is a value along the x-axis. This is my x-axis, and this is f of x. F of x, our function of the curve. And this value is x0. And I'm gonna label this the distance between x0 and this point to be h. It's distance from here to here, h. So this is x0. This point would be x0 plus h. This is x0, this is h, and this point would be x0 plus h right here. So the coordinate of this point would be x0, comma. This is the function f of x. So I'll plug in x0 into f of x. So it's actually f0, f of x. x0 comma f of x0, meaning the x-axis value of the x-axis is x0 and the value of the y-axis is f of x0, where you plug in the x0 into the function and you get the value of the y-axis. This is the y-axis. This is the x-axis. How about the value of this right here? The value of this point would be, what's the value of this point? The x value of this point would be x0 plus h. So I'm going to write down x0 plus h. And then what's the y value? Y value is plugging this value of x into the function. So it's f of x0 plus h. So the value of this point is x0 plus h, comma, f of x0 plus h. So these are 2 points in my secant line, which I've just drawn for you a few minutes ago. And what is the slope? Let's calculate the slope of the secant line. The slope of the secant line would be this value. Let's call it y of 1 divided by this value. Let's call it x of 1. So it would be this value divided by this value, which would give me the slope of the secant line. Okay, let me write it out now. Slope of the secant line is equal to y1 divided by x1. What's the value of y1? It would be the y value of f of x0 plus h minus f of x0. So y1 would be this value minus this value, not divide, minus, sorry. It would be f of x0 plus h minus f of x0. That's the value of y1. What's the value of x1? Well, the value of x1 is actually just h, so it's right, h. Okay, this is we've just drawn the formula for the slope of the secant line. Now we are going to find out what the fundamental basis of calculus and Newton's key insight as to why the tangent line, as to how the secant is related to the tangent line. And that was Newton's key insight, which enabled him to invent calculus. Okay, let me go on to the next page. Let me write it here. Newton's key insight to invent calculus. This is one of the fundamental ideas of calculus. I am actually able to say, look at this again, sorry, look at this again. I'm actually able to say to you that when the secant approaches the tangent line, I'll just draw a little red arrow here. When the secant approaches the tangent line, when the secant line approaches the tangent line, h at the same time gets smaller and smaller, because this point would go down the slope, and therefore the secant line will be closer and closer and closer to the tangent line. You see the secant line is here. It will get closer and closer to the tangent line as h approaches 0. So how do I write that in the formula? Well, it's very similar to this formula which I just defined for you. a few minutes ago. Let me write it out for you right now. So this is Newton's key insight, which I just said. Basically, his key insight was to say, or to observe, what happened to the tangent line at point f x of 0, comma f x of 0. So basically, Newton's key insight was to say that the slope of the tangent line equals the limit as h approaches 0. I like to cross my 0 with a slash to distinguish it from an O. And I'm going to use back the same formula as just now. Limit of f of x0 plus h minus f of x0 over h. That is the slope of the tangent line. This formula is exactly the previous formula. I'll just show it to you. You can see they're the same formula. F of x0 plus h minus f of x0, which is y1 minus over x1, is exactly the same formula, except that in this case I've added a limit to it. I'm actually saying as h approaches 0, I get the slope of the tangent line. Have a look at the graph carefully. You can see that as the secant approaches the tangent line, h does indeed get smaller and smaller. So this is such an important idea, and it's a fundamental idea of calculus, which is the limit. I'm gonna draw this arrow here, and I'm actually gonna fill it in because it's so important. So as the secant line goes towards the tangent line, h approaches 0, or you can say they are actually occurring at the same time. As h approaches 0, the secant approaches the tangent line. It may not get to 0, but as it gets closer and closer to 0, the secant line gets closer and closer to the tangent line. Okay, here is the slope of the tangent line is equal to the limit of h as h approaches 0 of this equation. And this whole thing is equal to the derivative of the function f of x at x equals x0. x0 is the point, please look at the graph again. x0 is the point where the tangent just touches the curve. This is x0. So what I'm saying just now is that the derivative of the function f of x0 at x equals x0 is equal to this formula, or conversely you can say the derivative of the function f of x0 at x equals x0, or at the point x0 f of x0. Okay, another comma. Okay, so this is such an important definition that I better put it in red, in the red box. So as you can see here, the derivative is equal to the tangent. So whenever we say what's the tangent, whenever we take the derivative of this function f of x at this point, I would actually get the same result as the slope of the tangent. We will go, this is the theoretical equation, but we will go into the actual examples where I plug in actual functions like x squared or x squared plus 2x plus 1. I'll plug that in with actual values, and you'll see what happens in the next lesson. This is the key insight of Newton, which invented calculus. He invented calculus from this key insight. Of course, calculus it was developed a lot more, but this was the first key insight. And if you want to understand calculus, the first step to understanding the whole of calculus is to understand this formula and the idea of the limit. The ideal limit as x approaches 0, or it can approach some number. Sometimes it approaches not necessarily 0, but another number. What happens to the function? That is the key insight of Newton. Talk to you again. See you again next lesson. Bye.